Hi, I'm Willemijn.
Hi, I'm Ali.
Hi, I'm Gergely.
Hi, I'm Hugo.
And we're the ISEC Nepal team working at National Innovation Center Nepal. And our product is
This
this
is not heavy at all.
this insulated solar electric cooker. And the primary goal we've had in our project here is to improve it mechanically to have it better suit local conditions after testing it on site and having user feedback.
So, while the office tour is playing on at the back, I will explain and justify the challenges of this project. Currently, 2.4 billion people globally are still using firewood to cook with. Biomass usage in cooking has many negative environmental consequences, such as deforestation and greenhouse gas emissions, as well as major health concerns caused by inhalation of smoke. One such developing country where indoor air pollution is a significant health hazard is Nepal, where 24,000 people, especially women and children, die due to smoke inhalation in their own households every year. To address these issues, our provider, the National Innovation Center Nepal, a non-profit organization aiming to promote innovation and development through local means, has collaborated with Professor Pete Schwartz from California Polytechnic State University, and together they have designed the Insulated Solar Electric Cooker, ISEC for short. The product is cost-efficient, able to be used in extreme rural and off-grid conditions, and is produced only with local materials, allowing it to be classified as a frugal innovation. The cooker, as you can tell by the name, operates on solar energy and aims to replace biomass usage in cooking practices in Nepal and tackle the issue of indoor air pollution. For the ISEC to have higher implementation levels, our team is tasked with conducting research in order to receive feedback from the locals and implement mechanical improvements to the cooker in line with said feedback.
It came to us as a surprise when our supervisor explained that the cooker had never been tested, so no one knew what to expect. That's why for the first few tests we connected a power and voltage reader so that we can establish the cooker's effectiveness. We did many water boiling tests, cooked dal, the most common local dish, kidney beans, soup and rice. With these tests we established that the cooker was not very efficient. Only about 60% of the power generated by the solar panels actually reached the food.
We made some initial modifications to the cooker before it could be tested with locals, including a clamp to hold the lid shut, handles for all the pots in order to stop people burning themselves when removing them, a frame to adjust the tilt and angle of the solar panels, a gasket to trap heating air inside the cooking chamber and act as a pressure cooker, and handles for the transportation of the cooker.
The research was conducted in Johnson, where 5 local women agreed to try out some recipes while we observed the process. The testing took place on the roof of our hotel for optimal sunlight. After 4 days of cooking, we conducted a group survey and asked about their cooking experience and their concerns. We predicted that the biggest concern was the size of the cooker, but the women agreed that the cooking time was the main challenge. The women also requested different cooking modules and a way to stir the food without opening the lid. This feedback has led towards our final design of the ISEC cooker.
Just hi? Oh, you already started.
Alright, here we are in our office here at the National Innovation Center. This is our magnificent cooker. I'll show you some of the features. So this is actually the newest edition. It's a stirrer. Inside here we've got the spoon that rotates around and mixes the food. We've got several modules of pot here. These handles are one of our additions. This is the big 7-liter pot. In here we can put different modules. Like for example, this is a steamer that we can put inside there. Another option is this big aluminum block called the STS, which we can heat up for many hours at a time to a high temperature, and then we can cook food even faster in it.
Yeah.
Locals expressed an interest in different cooking modules, specifically a Momo steamer, so we added a steaming module which sits above the 7-liter pot.
Some parts of the outer shell of the cooker feel warmer than others. This meant that the glass wool insulation was not uniformly distributed and thus did not work as efficiently as it could. As soon as we came back, we did some research into what the ideal density of glass wool is to conduct the lowest amount of heat, and then calculated the required weight of insulation for the corresponding volume in our cooker. We then removed all the wool, weighed it, added some more as there was not quite enough in the cooker, and tried to distribute it uniformly. The main problem of the cooker was the very long cooking time. To fix this, we decided to implement induction cooking, which directly generates the heat in the pot itself. In induction cooking, a constantly changing magnetic field, which is generated by an AC current in an induction coil, induces small currents in the pot itself, which generate heat. The issue was that it was a lot more complicated to generate the required AC current, which makes repairability in case of failure in rural areas very hard. It did not seem very frugal. One unorthodox alternative we found is called an axial flux generator. Basically, you just spin magnets to create an alternating magnetic field. Coils above the magnet then generate AC current, which is passed onto the induction coil, which can then directly heat up the pot. The energy from the solar panels would in this case be used to power a motor which spins the magnets. In the end, we built a few prototypes, with the final one showing a bit of promise. It could generate 10 volts with only 12 small magnets and 3 coils. In order to work properly, it would need to generate at least 30 volts. More magnets need to be added to achieve this. The higher cost that this leads to can be offset by using clean methods like wind turbines or natural water currents to generate energy instead of expensive solar panels. At the end of our project, we managed to have an improved but not finished version of the cooker. The initial modifications made usage much easier, as could be seen in the field tests. Other than that, we already improved insulation and implemented a stirring device and a MOMO module which can already be used. The main problem, however, which was the cooking time, still needs to be worked on, as the induction cooking method was not fully finalized when we left Nepal. However, with our extensive final report, which was one of the deliverables for the provider, we have set a good basis for the next team to work on this project. All problems with the cooker and potential solutions are presented. Also, ideas on how the induction heating element can further be developed can be found in this report. When this heating element is finished, further preliminary testing can be done to compare to the original cooker, and if it proves to be better, it can be tested in the field again.
To me, frugal innovation means creating something new where it is needed and for the people who need it. Frugality is using locally available materials or skills, so those people do not only benefit from the product itself, but also gain value from the manufacturing process or business model, and are able to sustain the innovation themselves without dependency on top-down entrepreneurs.
For me, frugal innovation just means trying to create stuff in such a way that people that are part of the bottom of the pyramid can experience a quality of life that resembles the one that we have in developed countries. For this to be possible, the product has to be cheap and sustainable. To achieve this, we have to use local resources and make simple products. Simplicity can be demonstrated in our example. Instead of a very complicated inverter to create an AC current, we simply spin magnets to have the same outcome. This is frugal innovation.
Frugal innovation is hard. In our project in particular, we really had to learn to balance the technical problem of building and modifying something in a resource-constrained environment with the social sciences aspect of trying to create something with real value to local interests and local needs. In the end, it was really all about collaboration, not just with potential beneficiaries, but with people all along the innovation process.
Frugal innovation means to me a solution to the problem of sustainable development at the local level, as most innovations are built to address issues of extreme poverty or developed areas in economic despair, like our project did in Jomsom and off-grid rural Trans-Himalayan areas. I also think frugal innovations as a concept and medium are necessary to elevate bottom of the pyramid areas and peoples. This is because of how intertwined having the local production means be at the local level of frugal innovations and how sustainable local development will function.